Testing. All right. Sorry guys, I haven't actually set up everything yet. Just bear with me. We're doing level 2 calculus today. What was I supposed to do last time? What did I do last time? I think I did kinematics. I'll wait for a few minutes as people are just arriving, and then we'll see what we can do. I was thinking about doing some optimization, but let's see what you guys want to do, and then we'll go from there. Oh, the 4 people that are here, what do you guys want to do? Optimization. I was thinking exactly that. All right. What I might do, Benjamin, is have a look at. Let me just set this up as well. Give me a second. Level 2 calculus live. Not lice, live. Noodles, you haven't actually sent me your address, because I sent out all the t-shirts today, and your t-shirt is still in my garage because I don't actually have your details. So could you please send me your email me your address, and then I'll send it to you. Possibly it won't go out till Tuesday. Now kinematics, Jax, we did that last stream, so I want to actually go and do a couple of optimization questions. I want to see, like, I can't remember what the optimization questions last year was, but like it was this one, the surface area one. Yeah, with the R in the denominator, which kind of tripped a couple of people. See, like these ones are really good to do. Do you guys want to do a graph optimization, or did this not hit the news? Yeah, the -1 did hit the news. Okay, so why don't we do something like this? I'll see if I can copy and get either Gemini or ChatGPT. Let's see who does it better. Always love pitting them against each other. Now this was 2024, so bear with me, people. I will just grab a question similar to that. Egg Shiglin. I don't know why you needed to, but thank you, but you didn't need to. Where is that? What question is this? Trapezium. Level 3 calculus 2024. Oh, I'm looking at differentiation. Oops. I was wondering why these questions looked a little bit harder. I was looking at the wrong questions. All right. Okay, let's see who comes up with a better question. Level 2. Ooh. Library. Level 2 question. Yep. Start with company knowledge. Similar question. Control V. Similar question and answer. Okay. Similar question. Oliver, your t-shirt is out. It should be coming very soon. 9 days enough for a triple E. More than enough, Jax. All right. I'm gonna give you folks a trapezium question first. Okay, let's do a simple one first, all right? And then we'll go into a trapezium one. All right, so where am I at? 26th. So here is the first question. Just a simple one, and then we'll get a little bit harder after we finish this one, all right? So probably a little bit too much zoomed in this bash. So there's our first question, and then what we'll do is we'll actually go slowly. We'll get trickier and trickier, but we'll start with that, all right? Oh yes, actually, Chiefs, you did send me a question. Where did I find that? Calculus questions, Oliver. Oh, yep. We can do that one as well, Oliver, because I think that's from. Yeah. I think we can definitely do that one. I'm sure I'll stuff up somewhere, but that's fine. We can do it. Let's start with this one. This is going to be level 2, guys. When's the next level? Next algebra and calculus live stream? Samal, that's in the bottom corner. You're going to see the schedule, or just jump onto TikTok or Instagram and you'll see my schedule up there. Yeah, easy, Oliver. Oliver, in that same thread, do you mind just chucking the answer? Otherwise, I don't want to waste people's time if I end up doing something stupid, which I probably will. All right, so I am going to go through this question now, just mindful of time. But like, I'll tell you what, maybe I'll give you another couple of minutes, give it a go. But if you want, I'll draw a little picture. So this is what it's. Why does it do this again and again? So what we're going to do is we've got a parabola like this, where 12 minus x squared. Well, that's a pain, isn't it? So the graph is going to look like this. Give me 1 second. Graphing. I think I did that wrong. 12 minus x squared actually looks like this. So where this is 12, and then this one here is going to be, that's a stupid question to start with. I should have given you guys a little easier question, but that's fine. We're going to go with square root of 6, is it? Let me just double check. No, square root of 12, not 6. Shift that, square root of 12. Yeah, there we go. So this is going to be square root of 12. This is going to be minus square root of 12. All right, so that's pretty much what the graph starts it like. So I'm going to leave it like that. That's the graph that you should have. You've got 32. Yeah, all right. Mello, if you want to know how I got that, like usually you will be given the graph, so you don't need to worry too much about it. But yep, sweet as Oliver. But basically, I've kind of just sketched the graph here because these questions are generated by Gemini, and like so they don't come up with the graphs as well. So you don't need to worry about it. You will be given the graph itself. Now, what the question's actually asking is that the rectangle is constructed with its base on the x-axis and the 2 upper vertices on the parabola. So if you think about it, the rectangle is going to look like this. And I mean, you've got a variety of different rectangles that could potentially happen, right? Like, so what we're trying to figure out is what is the maximum area possible. Now, what we're going to do is, if you look at the base of this rectangle, this here is going to be plus x, this is going to be minus x, which means the distance for the base of this rectangle is going to be 2x. Then, if you look at area's equation, area of the rectangle is going to be base times height. Now, the base is this part here, so that's the base. The height is this green part here. Now, the thing about height is the height at any given point of where you know, whenever x equals to that. So if I was to take this point, this little, I'm going to color it dark green here. This point here would be written as x, comma, the y value, right? That's how we'd write it as. But the thing is, we know what the y value is. The y value is actually 12 minus x squared. So this is what the y value is. So what I'm going to do is I'm going to replace this with x, comma, 12 minus x squared, because that's what the y value is. Now, once we have that, we can actually say that the height of this rectangle is equal to 12 minus x squared, because wherever the point is, so let's say if the point is here, then the height's going to be this pink line here, which is how you find that pink line is by substituting the x value in this equation to get the y value. So that becomes the height. So in other words, we've got base times the height. So then what we're going to do is area is equal to 2x multiplied by 12 minus x squared. So then area is equal to 24x minus 2x cubed. Now we differentiate it. So a dash is equal to 24 minus 6x squared. We put a dash is equal to 0 for max. So we're going to get 0 is equal to 24 minus 6x squared. Rearranging it, you're going to get positive 6x squared equals 24, and then x squared is equal to 24 divided by 6. And then x squared is equal to 4. X is equal to square root of 4. So x equals to plus or minus 2. Now, it's really important that we ignore the minus, because you can't actually have x as a minus. So therefore, x is a positive value. So we have to say that x equals to positive, as x can't be negative. Then we can find out what the area is. So the area is equal to 24x minus 2x cubed. So we got 24 times 2 minus 2 times 2 to the power of 4. 3, sorry, not 4. And what we've got is 48, take away 8, 16, and that gives you 32. All right, what I'm going to do is I'm going to put a bunch of lines. Let me know if you have any questions with any particular line, and I'm happy to help you out. Let me know. For max, A differentiate. What about for min? What do you do? B, pretty much the same idea. Like if it's max or min, you can always put down the differentiated function is equal to 0. But you do need to state it. You can't just put, you can't skip that line number 8 and just directly go to 0, because it's just bad practice. Okay, Kaliku, you don't need to know that part of it. That's just me giving you the sketch of the graph. In fact, I don't think you even need that part at all for this question. Thanks, Oliver. Stale, nah, you can just leave it as units. That's absolutely fine. I got you, Yonita. I just need to figure out how to kind of intertwine it with optimization. Were they optimization questions, Yunita? I can't remember. All right, so I got a few questions from all of, couple of questions from you guys as well. I think one of them is. I'll have a look. In the meantime, let me know if you have any questions with these ones so far. 34 emails, Yunita. Where did you send it, Yunita? Which one is this? We did the maximum height one. I got like 2 log questions from you. Oh no, you gave me right. You just sent this to me now. Okay, now I'm gonna hold off on those ones. Nah, sketching the FX, yeah, we'll do that. We only on excellence questions before the level 2. Chicken curry, no, I don't know, man. Like, just depends what the questions are like. So I can't spam excellence questions because it's like I need to find excellence questions first. Carcharodon's Astra. If you are struggling with the basics, just go on YouTube and just look for level 2 calculus in 10 hours playlist from my channel, and you should be good to go after that. All right, 10 hours, more than enough. Hey, Speedy Boy, welcome. We are doing exam questions, people, so trying to do exam questions. Yeah, definitely there'll be another Calc Live. I think next week will all be, like, I'll probably spend like a bit more time with you guys on Sunday. Because your exam's on Tuesday, right? Tuesday 4th? Is it Tuesday 4th? Yeah, Tuesday. So I'll definitely do Sunday, Monday, double sessions. Kevin, no idea, mate. No idea how that is. All right, I'll tell you what. Since we've got that question, I'll do one more optimization question. And then after that, I will start doing questions that you people have sent me on my email. So that's, I've got a list. Slow list that I'm working through. Just looking 2022 maybe. All right, I'm gonna try and give you a little bit more trickier question. This is an excellence question. Kesson, we're just doing calculus questions, but I think we just did one optimization, an easy one. Now I'm going to find a crazy one from a couple of years ago. It's a good question, actually. It's a very good question. It's just generating at the moment, and then I'll go through that question, and then after that I'll go through Oliver and the other people's questions. Ace, same with you. Go look at level 2 calculus in 10 hours. There's an entire video that's set aside for that. All right, here we go. Here's the next one. This is a little bit more work, but I reckon we'll be all right. So unfortunately, it's a repeat of the previous year's question, but the design looks something like this. So this is where the 2 semicircles are. So I'll leave this question for you folks. We are going to do... Man, come on. Now, I guess they generally, the marks tend to be a little bit more trickier, that's all. So they like to do that. All right, I want you guys to have a go at this question, and I've left a couple of little hints there for you as well. So I'm going to give you maybe about 4 to 5 minutes to try and work this through, and then we will, I'll actually go through the answer when we get through it. Yeah, Yonita, it is a 2021 repeat, just with a little numbers change. Unfortunately, GPT can't generate. Let me try and Google and see if it can generate a different one. Yeah, it's a good question there, Jax. Like, so certain formulas you will be expected to remember. So, like area of a circle, circumference of a circle, you'll have to remember those formulas. I don't think they'll actually give it to you in the exam. All right, now let's say I'm going to work on this very slowly. So if you're already started, then that's fine. Just keep going away. But just for the people that are kind of figuring out, area equals to 800 over pi. Yeah, so how do you actually start a question like this, right? So if you look at I think there is a hint that's been given in this. It says write the area of the logo in terms of R and H. Now, in this particular point, so what do we got? Pi r squared 2RH plus pi r squared. Oh, this is actually done the other way. Sorry, I'm just looking at this right now. I think I might have made a mistake with this question, but that's all right. We can figure it out. 2021 or 2022? I think it was 2022. I should have turned the shape the other way, but that's okay. We'll just do this. So if we want to find the area, which is this pink part here, we want to try and figure out what's the maximum area for this. I don't know, Kesan, we'll actually try and work it out because... So what you need to do is remember that you've actually got a rectangle. We've got to subtract the semicircle, the other part of the semicircle, to actually end up with this thing here. So I always like to start with the shapes first, because when I start working with the shapes first, then I could actually kind of get the formulas to work out. So here I've actually got h, which is the height. That's fine. I'm just going to leave it as it is. This part right here is the radius. So that means this part here is the radius, and that's radius, which is going to give me 2r. Now I've also got so if I write the formula for this, I'm going to get base times height minus the area of a full circle equals to the area of this little H shape that I have there. So base times height, now that's going to be 2r multiplied by h minus the area of the full circle is pi r squared equals area of the logo. Okay, I'm gonna pause there. Let me know if you have any questions so far, and then I'll carry on with the rest of it. But this question, I think there's only two main bits to it. Once you get the two main bits, you just have to differentiate, put it equal to 0 and solve. So the first bit is this. Okay, Oliver, I think you've got it that far. And I think this is what you need to do with optimization. With optimization, what happens is that you will end up with two different letters. And you have to figure out a way to get rid of one of those letters. All right, it's really important because for optimization, you cannot have two different lengths. You have to have everything as the same letter. In this case, we've actually got radius and then we've got height. So somehow we need to get rid of one of those two letters. And the way we're going to get rid of those two letters is by looking at the perimeter. The perimeter must be no more than 100 meters. So the perimeters, I think we should have put it as equals, but that's fine. So if I look at the perimeter of this, which is this orange line, this orange line is equal to 100 centimeters. So I'm going to take that separate here. Now, we know that this part here is H. This part here is R. So if I was to look at it, I've actually got two straight lines. So I've got one line that's H plus a second line that's also H plus I've actually got circumference of the circle, which is 2 pi r. And all of this is equal to 100. So in other words, I've got 2h plus 2 pi r equals 100. Sophia, are you talking about the 2r from here? So basically, remember that the radius of this circle is from here to here. So that's 1r. So if I look at the diameter, that's going to be 2r. So this part here is getting subtracted from here. And because this is equal to r, this is also equal to r. So when we add it up, we should actually get 2r. Any other questions, people? Because I'm just looking at the... We'll get to the h part because I don't know what h is. H could be 0. I don't know. I haven't actually done it yet. All right. So now that we've got the perimeter, I'm going to go back to the perimeter and I'm going to write h in terms of r. So I'm going to get rid of the 2. So yeah, this is definitely... Excellence. This is not hard, people. Like Oliver, trust me, this is not hard. The hardest part is coming up with the equation. Once you come up with the equation, it's so easy. The trick is get me 2 equations. One of the equations, you've got to get rid of a letter, and then you should be able to just do it. Like, watch what happens, all right? So I'm going to put 2h equals 100 minus 2 pi r, and then h is equal to 100 minus 2 pi r divided by 2. So h is equal to 50 minus pi r. Now, because h is equal to 50 minus pi r, I'm going to put it in a different color, sorry. I can now go back to my area equation and replace it with just get rid of the h there. So because I've figured that out, I'm going to go back from here and I'm going to go 2r multiplied by 50 minus pi r minus pi r squared. Now this whole thing is the area of the h value. So expand the brackets, I'm going to get 100r minus 2 pi r squared minus pi r squared. And what I end up with is 100r, I'm just checking everything, minus 3 pi r squared. Let me know if I've made a mistake here so far, because I think I saw 100 minus 2r 50 minus pi r. Yep, David, yep. Looking good so far. Okay, so next part, sorry, I'm going to come all the way here. I need to differentiate it. So when I differentiate it, I'm going to end up with 100 minus 6 pi r. Sophia, yeah, I think it's called in the level 2 calculus playlist. I pretty much spend a lot of time on optimization in episode 7 or 8. I can't remember. Okay, now we put area of h is equal to 0 for max. We're going to get 0 is equal to 100 minus 6 pi r. Rearrange it. 6 pi r equals 100. R is equal to 100 over 6 pi. Now at this point, the question's asking you just to figure out what the maximum area is. 50 minus pi r. 50 minus pi r. Wednesday, and after the level 2s finish, we'll be doing all level 1s after that, so don't stress. I don't think I'll have time to do that chicken curry. I did that last week. Come on, man, why you do this to me? Ah, Jack, that's unlucky. All right, so once we've got r equals 100 over 6 pi, we just asked to find what's the maximum area. So I'm going to go back to my area of h equation, which is 100 times r minus 3 pi r squared. So I'm going to get 100 times 100 over 6 pi minus 3 pi 100 over 6 pi squared. Should be lazy, but you know what? Over 6 pi minus 3 pi times 10,000 over 36 pi squared. Okay, I was trying to be clever, but I think I just have to use the calculator for this. If I can find my calculator. All right, so we've got 100,000 divided by 6 pi. I wonder if the calculator would give my answer in 6 pi. Minus 3 pi times and then divided by 36 shift pi squared. Okay, so my maximum area is going to be 265.25. All right, I know that was a huge question, so just bear with me. I'm going to put a bunch of lines. 6, 7, 8, 9, 10, 11, 12, 13, 14. I did plus pi r squared instead of minus. Oh, that's at the beginning you're talking about, Numair. This optimization question was a single E. Oh, interesting. They actually gave you the formula in that year for area of circle and circumference of the circle as well. It's nice of them. Garima, I think you can actually get an excellence with just getting a couple of excellence and 2 lots of merits. It's possible to get 20 points. In line 15, why do we differentiate? Because this is calculus paper, you will have to differentiate at some point when it comes to optimization, because you're trying to figure out when that maximum or minimum is happening. Bunny, you're fine for 265.65. I think as long as your working out is there, I think you'll be fine. Off the top of my head, Aryan, I don't know, but these are my... I don't know, man. Like, I think it might be 5 or 6. That looks... Oh, there you go. Episode 5 was optimization, starting at it. Yep. It would be episode 5 in that 10-hour playlist. I mean, I've got my notes there. I just haven't... I need to extract them, but haven't done that yet. Sorry. Back to this question. Isn't the answer 67.5? Where is 67.5 coming from? I don't know. Line 7. Okay. Line 7. Kesson, what I did was with line 7. Remember in line 5, my area equation has actually got an H and an R in it. And I need to get rid of the H or R. I can't have them both those letters there. I have to get rid of one of those letters. So what I did was, like, I went back to hang on, just gonna get rid of this. So I went back to the diagram, right? And the diagram, what I did was, like, I knew the perimeter, which is the orange line here. This orange line, when it adds up, it actually adds up to 100. So my first H is from here, my second H is from here, and my 2 pi r is the circumference of this circle. So those 3 components add up to 100. Once I got that, then I can rearrange it to write H by itself. Then I can go back and replace H in the area equation. So that's what I did. Yes, Kesson, and that's always going to be the case with optimization. You always will end up with 2 letters, and one of the letters you have to rearrange it so that it comes back in that first one. Now, if you go back to the previous question, look at the previous question, right? Because this part here was the y value. So if I did the area is going to be x times y. Now, I can't differentiate that because I have a y. Because I have a y, I can't differentiate it. So I need to get rid of it and replace it with the 12 minus x squared. So now I got everything in x, so I can actually differentiate. That's the whole point of optimization. So no matter how hard this optimization question gets, there's only 3 things you need to remember. There's going to be one equation with 2 variables. The second equation, you have to rearrange and eliminate a variable. The third part is you differentiate, put it equal to 0, and you're done. That's pretty much optimization in a nutshell. Yeah, Oliver, that is the tricky part. You look at any one of these excellence questions, right? And this is even at level 3. This is the same problem people have at level 3. It's not the differentiation. The differentiation part is the easy part. But you have to always keep in mind that you will have an equation with 2 letters. The second part is they'll give you some sort of information to get rid of one of the letters, and then you're good to go. All right, just because Yonita is asking, and she's been asking me for a while, I'm going to go find that question she sent me, and then Oliver, have a look at your question as well. Yonita's question is a nice, easy one. I'll start off with this, because this one is like literally an achieved question. It's super easy, and I think you will find it a lot more easier as well. Yeah, I did wonder about that, DJ Nam, but to be honest, I don't think they would say no more than they should have said equals to, but this was ChatGPT trying to be clever. Well, there you go. Stale's got a good point there. Noah, I don't think it matters. You could have gotten rid of R, but the problem with getting rid of R is you will then need to substitute it twice. So imagine it like this, right? Let's say you do R. I'm just going to do this here separately. So if you were to do R, you're going to get 2 pi R equals 100 minus 2h. Then what happens is you would get R is equal to 100 minus 2h over 2 pi. Now, the problem with substituting R is you then have to take this R and you have to substitute it here. You then have to take this R and you have to square it to substitute it here. So what ends up happening, Noah, is you've actually created more work for yourself. Doing the H would be easy because you're only getting rid of one letter. But if you do R, you have to do R squared here, and then you have to do R, and suddenly you've created more work for yourself. Hopefully that helped you, Noah. All right, this is Yonita's quick fire achieved question. Very quick one while I set up the next one. I'm finding yours, Oliver. Hold on. Oh man, you have written all over this, Oliver. No worries, Noah. No worries. You're welcome. Now, folks, honestly, which playlist episode is that? Let me just check. Part 8 of that playlist. Yeah, if you can, Oliver, send the clear one without your working, then I can just cut and paste. All right, let me have a go through this question here, because this question is really onto it. Real quickly. So just going to sketch a similar type of X and Y axis, except this is going to be Y dash and this is going to be X. Now, one thing I'd always say to you guys is this, is like, if you can look at a graph and you can kind of guess what shape it is, then you can actually differentiate it straight away and then just get a rough idea. So for example, this graph here looks like this, which means this is a negative x cubed graph. Now, I don't care about the rest of the parts of this equation. I'm sure it's negative x cubed or like plus something else, blah, blah, blah. Doesn't really matter. The only thing we care about is the first element. Now that's a negative. It's a negative x cubed, which means when we differentiate negative x cubed, you're going to end up with negative 3x squared. So in other words, this resulting shape should be a parabola. All right. Now, again, we don't care about the rest of the parts because the only part we care about is what does this particular part look like? And that's a negative 3x squared. So it's going to be a parabola. So the only thing we need to figure out is its 2 points, the 2 turning points, which is going to cut where the gradient is equal to 0. To do that, all you have to do is, if I can find my ruler, I don't know where my ruler went. I had a ruler, but this is the latest update. I've lost my ruler. That's fine. So basically, let me just go like this. There's a 0 there, and there's a 0 there. This is a turning point. This is a turning point. And so as long as your shape looks something like this, you can easily get an achieved for that. I'll have a look, Oliver. Yeah, got it. It's a bit dark, but I'll try my best. Oliver, what I might do is do you want a similar question, Oliver, or should we do the same question? Jack, yes, all of the live streams will be posted on YouTube, my friend. If they come from I think the closest I've seen is a merit. I don't think I've seen it as an excellence question. All right, we'll do this one. All right, this is the one that popped up here, and I hope you guys can see the question. If not, I'll just write it up. So you've got I actually like these types of questions because, to be honest, they give you all the information you need, and it's just a matter of substitution, folks. Like, seriously. Rotate. Oh my god, I cannot believe I just did this. I just rotated an image in Microsoft Paint. I feel old. All right, team. So for this one, it's a set of simultaneous equations that you need to do. Like, I'm not even gonna worry about drawing a graph, right? Because what it tells you here is it has a tangent to the curve at -1,8. So basically, this is some of the points that you already have. -1,8 is one of the points, and another tangent to the curve at 413. So this is another point right there. So that's your first kind of starting kind of things, and then we'll actually work through from there. All right. Same gradient as the point touches. Tangent. All right, I'm gonna sketch this out because I got no idea what this looks like. Has a tangent to the curve at -1,8. Curve at 413. The tangent at -1,8 cuts at 0, -1. So this tangent cuts it at 0, -1. That is -1,8. That one there is, what is it? 413. Ethan, embarrassing moments are what makes us, man. Like, I mean, I'll tell you what, like, we can sit and have a yarn about after this question about the amount of embarrassing things that I've done. Constantly, I do something stupid all the time. But the best part is you learn from it. I think if you don't laugh at yourself, you'll always be kind of worried about, getting embarrassed. I think you can do that. I used to be like that. Like, I used to be like, oh man, if I do this, I'm going to embarrass, people are going to laugh. But to be honest, is when I stopped thinking about what other people think and just do what I wanted to do and just have fun. Didn't matter if it was embarrassing, as long as I had a laugh and I felt good. And if it was a mistake, sometimes I make those mistakes. It can be embarrassing, but you get up and you kind of just move forward, because the more embarrassing moments you have, the more kind of you step out of your comfort zone. Okay, all right, let's go through this question. So hopefully she can. What is this? Danica, like, yeah, that's part of life, Danica. Like, look, right now, I'm going to tell you, there's going to be an embarrassing moment very soon, because I am going to stuff up this question at some point, and these guys are going to go on chat, and they're going to be like, sir, you forgot a minus, or you forgot a plus. And I'm like, oh, man, like, it's going to happen, it's all right. It's okay. It's part and parcel of the game. All right, as for me, now I'm trying to visualize this question, and I'm kind of struggling, and you know what? Let's just go with the -1, 8 and see what happens. So if I put x equals to -1, because I know that we've got -1, 8 as a point. So that means I could actually put y is equal to ax squared plus bx plus c blah, blah, blah. And I'm going to get 8 is equal to a -1 squared plus b times -1 plus c. So what I've got here is 8 equals to a minus b plus c. The next one is I could do this. I could do 4 and 13. And I can write 13 is equal to a times 4 squared plus b times 4 plus c. So I've got 13 equals 16a plus 4b plus c. Now, what I can do from here is I can actually get rid of the c value. Now you might be wondering, hang on, how do you get rid of the c value? Well, because both of these equations, if I was to write them on top of each other, like, just give me a second, let me just show you this. If I write 13 is equal to 16a plus 4b plus c, and below it I'm going to write 8 equals a minus b plus c. So what I'm going to do is I'm going to subtract 13 minus 8, 16a minus a, and then 4b minus b, and then c minus c. All right, now the reason why I'm doing that is because I can actually get rid of the c value and just have a and b. So 13 minus 8, that's going to give me 5. 16a minus a is going to give me 15a. 4b minus b minus b is going to give me 5b. So really, I can divide everything by 5. I've got 1 equals 3a plus b. Yeah, you could do that too. I think you do have to differentiate, because it's like -2. The only thing is, I'm going to differentiate it. Let's just see what happens if I differentiate it. If I differentiate it, I'm going to get f dash of x equals to 2ax plus b. That's my gradient function. What else can I do? What else can I do? All right, here's the thing. I'm just going to leave, I'm going to park that there for now. I'm going to come back to it, that 3a plus b equals to 1. I'm just going to see if I can work around it. But what I'm going to do next is, what did you do? Then m equals to 2a minus 1. Yeah, that's what I was going to do, because I was going to look at this graph here, this line here. This yellow line actually, no, I was going to do something even more cheekier than that. And let me know. I'm trying to think if I'm allowed to do this, because let me just pause and just think this through. Tangent at negative 1,8 cuts the y-axis at 0, 1. Guys, here's the thing, right? Like, I'm going to do this completely different how the answer schedule actually is done. And I don't know if I'm going to be right, but I'm going to give this a go. Now, the yellow part of this, the yellow part is the gradient, right? But we've actually been given what the gradient is. Because if you think about it, look at this. We've got rise over run right here. That's rise over run. So this is going to be 9, and this is going to be 1. So the gradient is actually minus 9. Would you guys agree with that? So if the gradient is actually negative 9, so gradient is equal to negative 9. I got the gradient from the blue part there, which is just looked at rise over run there. That's all I did. I got negative 9. The next thing is I can actually say, so f dash of negative 1, so at negative 1 the gradient is equal to negative 9, because it's a straight line at that point. So then I could say negative 9 equals 2a times negative 1 plus b. So if that's the case, I'm going to get negative 9 equals negative 2a plus b. Now I've got two simultaneous equations, because here I can say b is equal to 1 minus 3a. Then negative 9 equals negative 2a plus 1 minus 3a. So I'm going to get negative 9 minus 1 equals negative 5a. Negative 10 equals negative 5a. And then a is equal to 2. And I'm hoping I'm right. Yeah, a is equal to 2. Then b is equal to 1 minus 3a. So b is equal to 1 minus 3 times 2. That's negative 5. B is negative 5. I need to figure out what the c value is. C value, where can I go for c value? Oh, there we go. 8 equals a minus b plus c. So 8 is equal to 2 minus negative 5 plus c. So 8 equals 7 plus c. C is equal to 1. Now I forgot what the question's actually asking me. I've got find the values of a, b, and c. Find the equation of the other tangent. So I've got the point, which is 4 and 13. I need to find the gradient at 4. So f dash of 4 equals, I'm just going to get the equation 2ax plus b. So f dash of 4 equals 2 times a, which is 2, x is 4, plus b minus 5. So the gradient is equal to 8, 16, 11. So I've got the gradient, which is 11, and I've got the point, which is 4, 13. So y minus y1 m times x minus x1. So y minus 13 equals 11 times x minus 4. 11x minus 44. And I've got 11x minus 44 plus 13, which is going to give me 11x minus 31. And I'm looking at the final answer, and that is what it is. But I'm sure you've got a ton of questions here. So bear with me and I will answer each and every one of them. I just realized I stuffed up my line numbers, but that's all right. That definitely took a much longer way to explain the answer to you folks. But no, I don't want to save this work. Don't save. All right, let me go through your questions here. Sorry, I missed a whole bunch of chat from the previous part. I thought I was doing... Nah, Bob the Builder, you never stop. You just keep going. Elite, no, all of this gets saved in YouTube, so you can always go and watch it there. Bunny Dog, I don't know where you... I would like to know where I made a mistake, but I think I just saw the question and I just like, well, I'll just go through it. Shot, chicken curry, got it. Now, Finn, I think it's a really it's a good these simultaneous questions are a good way to kind of get used to them. Kesson, remember, like in this part here, they said that the tangent is at 1,8 and it's actually touching it at 0, -9, 0, -1. That's a straight line. So if this is a straight line, what we were going to do is gradient is y2 minus y1 over x2 minus x1. So this would become y2 and y1. This is, no, sorry, x2 and y2, x1 and y1. So when we do this, we're going to get -1 minus 8 divided by 0 minus 1. So you get -9 over 1. That's how you get the gradient as -9. Oh, this is definitely an excellence, Maying. Like, there's no way this question's like... Stale, yes, I'm sure you could do that too. But like I told you, you could set up a second tangent at 413. But I'm just trying to think, it's like, I wouldn't know... Like, what would you do? You could go f dash of... But you don't know what the gradient at 4 is, right? It doesn't tell you. Uh, 30 is for actually answering the second part of the question. Because if you look at there's two parts to the question here. One, it says... find ABC, which we did. Then the second part of it is the second part of it is equation of the other tangent. So everything from step 30 onwards or 29 onwards is to find the equation of the second tangent. Yeah, Kaliko, you can also do that as well. This is level 2 calculus, Archie and can't believe I said that out loud. Almost 40 steps. Yeah, that's my bad. That's because I did a lot. Which one would be C from points? I'm lost. Yeah, that's another way, but I think in this case the C... No, Kekaliko, it's... That won't work because that's not the C value though. Because the parabola could look like something like this. So your parabola could look... I think the parabola looks like this. where this part here is the C value, which equals to 1. That yellow one is the intercept for the tangent. Yeah, user. So this C equals to 1 is this part here. So when we find C equals to 1, we are actually looking at the parabola's point where it cuts the and I don't know if that looks like that. I could be completely wrong. It could look something like this as well. You know what I'm saying? So I'm just rough sketching it right there. Yeah, Bob's right, because it is the C actually depends on the parabola touching the y axis. No, I don't. Look, Oliver, I think this is just one of those questions that was just long, but I've seen a few questions like that. On line 6, could you also use the coordinate 0, 1 instead of -1, 8? Could you use 0, -1? Yes, you could use 0, -1, because if you use 0, -1, what would... No, hang on, would you? Why would you use 0, -1 in line... Sorry, which line was this again? Line 6. Well, you could say f dash of 0 is... No. Because 0, 1... No. Because that's a different one. Sorry, who was it asked? Fuzzy Tank. No, you can't. You have to use the tangent point, not the y-intercept point. Because at 0, -1, the graph is actually not going through 0, -1 at all. So you can't use that point. You have to use a point where the tangent is actually touching the parabola. Bob, I think this was from the D&D one. I don't know, JM, because like they tend to mix the questions up. I mean, you can expect kinematics, because I think one year everyone prepared for kinematics and then there was like one merit question in it. I've got no idea, Bunny. Like, I don't actually answer those questions. But guys, look, that's pretty much us for today. I'm going to go through probability tomorrow. Having a look at the schedule, we're going to do like 3 sessions of level 2. And I'll tell you what, like I'll see how I go on Friday night. If I'm up for it, then we could do another calc session on Friday and Saturday. And we might as well just go all in till Tuesday, November 4th. Let me know if you guys are keen, and then I'm happy to run it. Bhavik, I usually post it on Instagram and TikTok, but also it's right at the bottom of this stream here. All right, let's see how I go on Friday night. If I'm good, then we'll do some calculus on Friday night. User, what I would say is go do the other level 2, 3, not level 2, 3, the 15-hour and 10-hour playlist, and then come back, and then we'll go through it, and you'll find it a lot easier. Elite, which one you doing? Are you doing all 3 externals or just a couple? Now, Oliver, I'm done for today. I'm losing my voice already. I gotta do a few more little jobs off my list. By the way, can I, Oliver, if I want to show you guys the glow in the dark shirt, but it's pretty neat, I have to say. I'll see if I can show you a video of it. Now we're done. Yeah, we're done. I'll post the video later of the glow in the dark shirt. Fuzzy, I have the same. Fuzzy and Sophia, I would say do both. No, not the Walker Mats books. The D&D books are different ones. Oh, yeah, we're done Elite. We usually go 8 o'clock every night. I don't have access to those papers, team. That's exam papers is usually from the schools. Hey, exam, like honestly, where is it? Which playlist? Part 6? No, part 7? Part 8? Okay. Where is it? Who was it that was asking for kinematics? Exam. Part 9 of the level 2 calculus in 10 hours playlist. Part 9 is all to do with kinematics. Oh, wait, you think that's funny? Wait till you see the number of subscribers I got. I got 66K and getting close to 7. Can't believe I said it again. Now, the difficulty is like, I think, like every question, if they're difficult questions, then it's good for you guys because it's like you can go through the answers and figure out how to do it. Oliver, I don't know if you're still here, but I wanted to show you what's on the way. All right. This is what it looks like, but I need to figure out how to reverse this video, and I haven't actually posted it yet, but I will post it. But long story short, let me just add this. This is what the t-shirt looks like, Oliver. Where is it? TikTok video, Google Photos. There you go. I don't know how to film it with glow in the dark, so I've just filmed it with like a little bit of yeah, I just moved it around with a little like my 3D printer filament holes. Connor, we just did a little bit of random questions, couple of excellence questions, and then a couple of achieved questions as well, so nothing major yet. Bunny dog, I could, but I'm too lazy. If I was to differentiate it, now I think you have to use the gradient at some point, Bunny dog. Yeah, I thought so too. Like I needed to make one for myself. I don't actually have one for me, but like it looks normal when you wear it, but then in the nighttime it starts glowing. I was like, this is cool. I like this. Hi Senzi, how you doing? Thank you. Also the other one, like, because I know most of you folks are on. If your school is Google, then you could get Gemini. I think you should get Gemini for free, so you can just chuck it on Gemini Pro as well. My schedule for calc, Connor. No, at the moment my schedule is tomorrow I'm doing probability. I think a couple of days later I'm doing algebra, and then these guys have asked for calculus again on Friday. So yeah, just keep an eye on it. Hey Joe, I've finished my tomorrow's probability level 2. Yeah. I don't know, Oliver. Like I know that a few folks have said that it's given them luck to wear a t-shirt, but I doubt it. think it's more about how much you prepared for it. Tomorrow is going to be, it's always 8 p.m. team. Always 8 p.m. Yeah, prelim is just another way of saying derived grades. So, all right, team, that's me done for today. I'm going to go and actually, I need some sleep. But I'll see you guys tomorrow for level 2. Take care till then. As always, thank you for watching, and just need to get rid of my little t-shirt thing that just keeps going round and round. But yeah, take care, and I will see you tomorrow. YouTube, have a good one, and keep practicing those exams. And of course, send those, if you do have any final questions, send it. I'll try and do it during lives. Sometimes it's hard because I can't answer every question. I try and pick questions that can work for everybody. I like that last question because I think it gives you guys a lot of things to learn. And if you do get a question like that, then at least you know how to manage it. Yep, all good, Kesson. All right. Thank you, folks. YouTube, as always, thank you for watching. See you later. I can never click on this because I get another... there we go.